This is it, Algebra. This is our last video lesson for the year. Your final assignment will be on Alex, and we're going to be talking about probability a little bit more. This time, what if the events aren't independent? So what if they are dependent? And the easiest examples that I can think of for something like this is bingo and the lottery. When you start off with bingo, you have 75 different numbers that you can choose from. But as soon as that one number is called, now there's only 74 left. So say you're hoping for B10. All right, so at the very beginning of the game, there is a 1 out of 75 chance that you're going to get B10. But if, say, 073 is called, and you're still hoping for B10 the next time, well, that changed the odds now because there's only 74 numbers left. So now there's a 1 in 74 chance. So that's considered dependent events because the first event, the O ball being chosen, it affected the probability of the second event of B10 being chosen. So that's the difference between independent and dependent, but calculating the probabilities of dependent events is actually the same. You're still going to multiply the probabilities together. Just the difference is the probability might change for the second round. So let's go ahead and take a look at a few of these problems on Alex. So here we go. We got the classic bag with different marbles. In this case, they're starting off with 9 marbles. We got 4 green, 3 red, 2 blue, and they want to know. And the important part here is when they say Raphael is going to choose a marble at random. What we have to consider is without putting it back. All right. So without putting it back is meaning, okay, we're going to start with 9 marbles, but then after that, there are only going to be 8 marbles. All right, so that's an extremely important part to remember. And sometimes they call it replacement, with replacement or without replacement. So you have to pay attention to that wording. All right, so they want to know probability that the first marble is blue. So this first fraction, we have 2 out of 9 marbles that are blue. So the probability that the first one is blue is 2 out of 9. And then the second marble being green, there are still 4 green marbles left. But remember, there are only 8 total marbles left. So when we're looking at this, we're looking at 2/9 times 4/8. And we could simplify this to 1/2 if we wanted to make the multiplication a little bit easier. So we would get 2 out of 18. I didn't realize that I could have simplified these as well, but either way, we're going to get 1/9. So there is a 1/9 probability that the first marble will be blue and the second marble will be green. So let's move on to another question. A radio disc jockey has 7 songs on this upcoming hour's playlist: 2 rock, 3 reggae, 2 country. That's a diverse radio station. And he chooses the first song to play and then randomly chooses a second song to play from the remaining ones. Meaning, once again, once one song is played, you take it out of the mix. So there are 7 to begin with and then 6 after that. So what's the probability that both songs are reggae songs? So this is actually slightly different from the one that we just did. So we're looking at 3 reggae songs out of 7. And then the next time, once we chose 1 reggae song, there's only 2 reggae songs left out of 6 remaining songs. So we're looking at 3/7 times 2, 6, because once again, we're going to multiply these probabilities together. I want to simplify at the end here this time. So I have 6 out of 42, and that will simplify to 1/7. So there's a 1/7 chance that both songs that they are choosing are going to be reggae songs. Let's go ahead and look at just one more. These are all going to be pretty similar. You get the idea. So internet research company surveyed 95 online shoppers, each of whom made 1 purchase today. Company recorded the type of purchase, so 18 clothing, 25 pet supply, 40 beauty supplies, 12 office supplies. This time 3 shoppers are chosen at random. So we're going to have 3 probabilities to talk about. And there's that word I was talking about before, without replacement. So that means that they're not putting it back. So when they start with 95, with replacement would mean that it's always out of 95, but in this case, without 95, so it's going to keep going down. So what is the probability that none of the 3 shoppers purchased clothing? All right. So first one out of 95. I think it's probably smarter here in this case, since we don't want clothing, is to subtract 18 from 95 to figure out the no clothing there, right? So that's going to give us 77. So 77 people didn't purchase clothing. And then after that, if one of those people are chosen, that means that there are 76 people left out of 94. And then after that, there will be 75 left out of 93. All right, so 77 out of 95 times 76 out of 94 times 75 out of 93 will give us a probability that none of the 3 shoppers purchased clothing. And then what I want you to also keep in mind here, they say do not round your intermediate computations and then round to 3 decimal places. So what they don't want you to do, they don't want you to change these individual fractions to decimals and multiply them. They want you to just multiply everything as it is and then round at the very end. All right, so that being said, this is kind of what it will look like. Let me pull up the calculator here. So it was 77 out of 95 times, and then it was 76 out of 94, and then 75 out of 93. So this is what they want us. This is the end computation, not the intermediate computation. So to 3 decimal places, we've got 0.528 here. So 0.528. Check this one just to make sure that we did everything correctly. And we're good. Oh, I got yelled at because I didn't put a 0 in front of it, but no big deal there. So once again, multiply, but keep in mind that the total amount is going to change with the dependent events once you choose things without replacement. And this is the last hurrah for algebra for the year. Thank you for a great and a weird year. I appreciate all of you, and reach out to me if you ever need anything for this assignment and obviously anything else in the future that may come up. Good luck.